We've been asked to integrate this rational function, x squared plus 4x plus 1, all over x cubed plus 3x squared minus x minus 3 with respect to x. I'm going to begin by rewriting the integrand. And my actual goal is to integrate this using partial fraction decomposition. So I'm just going to rewrite the integrand that we saw just a moment ago. And since I think I'm going to use partial fraction decomposition, I'm going to first factor the bottom. And I think I can factor by grouping. If I look at the first two terms and the second two terms, I can factor out an x squared from the first two terms, leaving me an x plus 3. From the second two terms, I can factor out a minus 1. I see the same binomial expression here, which means I can now continue to do my factor by grouping by factoring that out front. Factoring out the x plus 3 leaves me an x squared and then a minus 1. Left a 1 off the top there, should sneak that in there, and that leaves me with x squared plus 4x plus 1 divided by x plus 3 times x minus 1 times x plus 1. So now I can do a partial fraction decomposition on this. And what I'm actually going to do first is rearrange the bottom just a little bit. And this part's not necessary. To be honest, I'm going to rearrange it so that my factors appear as the x minus 1, x plus 1, x plus 3 for no other reason than that's actually what I did when I worked the problem out before the video. It doesn't really matter, but since I've gone through the trouble of working this problem out before I started making the video, I might as well make my A, B, and C match what I had done earlier. I probably would have written it down as an A over this, a B over this, a C over this, and at least this way I'm doing the same process that I did before, and I won't have to think about which variable is over what now. So not really necessary to rearrange it there, just a convenience for me in making the video. If I multiply both sides of this final equation by the bottom, I will get x squared plus 4x plus 1 is equal to A. And when I multiply the bottom over, the x minus 1s will cancel. I'll be left with that x plus 1 times x plus 3. And I'm going to go on and multiply that out. X squared plus 3x, 1x more gives me that 4x plus 3. B times the x plus 1 will cancel. I'm going to go and multiply these two together. I get x squared plus 3x minus x. So that would be a plus 2x and a minus 3. And then finally plus c, and the x plus 3's cancel, and I'll be left with, and I know that was originally an x squared minus 1. That actually shows up in my factoring there, so I don't have to think too hard, and even if I did, multiplying those two together is pretty easy. So finally, let's get the things with the x squareds together. I'd have an ax squared plus a bx squared plus a cx squared, so a plus b plus c all times x squared, thinking about factoring. The linear terms, I'd have a 4ax, I'd have a 2bx, and this piece doesn't have a linear bit, so those are my only parts times x. And then finally, a constant term, 3a minus 3b minus c. Now our job is to equate coefficients and create a system of linear equations that we'll have to solve. Well, a plus b plus c must equal 1. 4a plus 2b has to equal 4. And 3a minus 3b minus c is equal to 1. Now I need to solve that system of linear equations. And what I'm going to do is imagine this is a first equation, a second equation, and a third equation. I'm going to imagine adding equations 1 and 3, which would give me a 4a minus 2b. The c's cancel, and that's what I was actually going for, is equal to 2. Giving me an equation in just a's and b's, and if I look here, well, I have another equation as only in A's and B's. Don't know where that 3 came from. That's a 2b. And since this already has a minus 2b and a positive 2b, I'm just going to think about adding those two equations together to reveal what a is. So I have 8a is equal to 6. Divide everything by 8. I'd get 6 over 8 briefly, or that a is 3/4. Now that I know what a is, I can plug it back into either one of these equations to find b. And very quickly, you would find that b is equal to 1/2. Having values for a and b, you can plug them into this first equation to very quickly find out that c is minus 1/4. And I invite y'all to go on and show the work there and fill in the missing details. But this lets me write my integrand in terms of these coefficients. I constants on top, plug the 3/4 in, plug the 1/2 in, plug the minus 1/4 in. So I'm going to quickly do that just off camera, and then we'll get to integrating. So, having done the integration by parts and knowing the values of a, b, and c, my integral becomes this. And this is pretty easy to integrate. I can imagine that 3/4 sitting out front of a 1 over x minus 1. So my antiderivative would be 3/4 times the natural log of x minus 1 in absolute value. And each one of these nice happy bits has a similar antiderivative. And there we have it. We've arrived at the end. The hard work all appears in doing the partial fraction decomposition. The actual anti-differentiation, not that bad.